Hello, my dear students. Welcome back to Pen and Paper Chemistry on YouTube. You just need a pen and a notebook with you so that you can understand the content taught on this channel. This video is about carbon and its compounds related to grade 10 curriculum in most grade 10 syllabus in most of the curriculums, that is GCSE, ICSE or even CBSE. And this is part 3 in the series of videos. Since there is a continuity in the content matter being taught, my advice to you would be to follow the videos in the respective series, that is part 1, part 2, part 3 and so on, so that you are able to understand when we go ahead with our learning. So let's get started. Now in part 2, I had introduced to you the simplest organic compound, methane. And based on methane, we had built up a series of compounds. So let us now tabulate these compounds. So you had the compounds wherein there is only single bond between the carbon atoms, which are also known as saturated compounds. When there is only single bond between the carbon atoms, the particular organic set of compounds are known as saturated compound, or that compound would be known as saturated. Now, in that series, the first compound is CH4, C2H6, C3H8, C4H10, and so on. And you know how to go on to the next compound in the series. Do you or you don't? Try and recall. Yes. Similarly, we had done a set of compounds wherein there is a double bond between the carbon atoms, and there also we had gone on to build a series. There is triple bond between the carbon atoms. What is the name given to such type of compounds which have double or triple bond between them? Yes, they are unsaturated compounds. This is also unsaturated when it is forming more than one bond between two carbon atoms. So it could be a double bond or it could be a triple bond. The compounds that we had formed, we have again listed them in a series. There was something interesting as well that we had observed between any two compounds in the series. You see, they differed in the CH2 group between any two compounds, between any two successive compounds. Successive means coming one after the other. There is a difference of the CH2 group, and every time we wanted to form a new compound, I just had to add a carbon and two hydrogen to it in order to get the next compound in the series. And the same applies for the unsaturated compounds as well. So when you have this wherein the successive members are differing by CH2 group in any series, see carefully. Write down these compounds yourself and you will be able to see the clear picture. Don't just, sit there. Try doing it yourself. You will find that you will feel less sleepy and less bored as well. Okay. Now CH2 means the atomic mass of carbon is 12. The atomic mass of hydrogen is 1. So 1 into 2. That means they are differing by a mass of 14U. 14U. So here also differing by CH2 and a mass of 14U. So interestingly, in these saturated compounds, or more specifically hydrocarbons, because they are made up of only carbon and hydrogen. Between successive compounds, they are differing by CH2 group. They are differing by a mass of 14 and they are similar in their chemical behavior as well. As we will see, they are called alkanes. This is a new word that we are introducing for you now. This set of compounds, hydrocarbons, which are which have only single bond between the carbon atoms are known as alkanes. So you see, this is a series which can go on and on and on like this. Keep on adding a CH2 and you will get a series of compounds, C6H14 and so on. This series of compounds is applicable or present in compounds, different sets of compounds. So when you're talking about double bonded compounds, this series is there. Triple bonded compounds have their own set of series over here. This is what we call as the homologous series. And this is what we are going to discuss in detail today. So let us first define homologous series. It's a series of organic compounds with the same functional group, substituting a hydrogen in the carbon chain. Now, what do we mean by this functional group and all? Don't worry. As I always say, this will get sorted out because this is a totally new concept and you are learning many new terms in this chapter. Keep on writing them down. So, the word that you learned was organic. The word that you learned was you are learning today is homologous. The word that you learned was hydrocarbons. These are all important terms for this chapter. So if I have to define it simply, I will say homologous series is a series of organic compounds wherein the successive members are differing by the CH2 group and by a molar mass of 14U, and they have the same functional group. Now, is there a functional group in saturated compounds? No. This is the simplest set of compounds that we have, wherein there is only single bond between the carbon and the only other atom attached is hydrogen. But if I have a doubly bonded compound, so the hydrogen is replaced by a double bond. If I have a triply bonded compound, the hydrogen is replaced, two hydrogen are replaced by another bond. So that gives me a triple bonded compound. Now, because of the presence of this double bond between the carbon atoms, or triple bond between the carbon atoms, the properties, the behavior, the chemical behavior of these compounds becomes very different from the chemical behavior of compounds wherein there is only single bond between the carbon atoms. So you see, the triple bond, the double bond, they can be classified as functional groups. That means which define the function, those groups which decide the chemical properties of that compound are known as functional groups. Yes, take time to absorb this new term. So, what is a functional group? A functional group is a set of atoms or a single atom which characterizes, decides, plans, affects the functions. That means the chemical properties of an organic compound. That is what we call as a functional group. A set of atom, you can even say functional group as an atom or group of atoms which affect the chemical behavior of an organic compound. That's how you define. This could also include the double and the triple bond. We will come back to this a little later in this video itself. Let's go back to the homologous series, wherein we said that the successive members are differing by CH2 group, a molar mass of 14U. Now I'm going to show you something very, very interesting. So let me first get rid of the extra stuff over here on the board. Now see over here, CH4, C2H6. Do you notice any relation between the number of carbon and the hydrogen? So for one carbon, there are four hydrogen. For two, there are six. So for three, there are eight. What do you think for four carbon atoms, how many hydrogen will be there? The mathematicians in the group, the people who can apply logic. Come on, try it. Yes, I can represent these formulas or these compounds by a simple generic formula CnH2n plus 2. So that means if I am talking about the fifth member, I will put N as 5 and I will substitute the value over here and I get C5H12. Let's see, is that right or not? Okay. So just add CH2 to C4H10. What do you get? C5 and H12. There you go. Okay, can you give me the sixth member in the series? Go ahead, give it a try. First, try with the formula. Let's put the value of N as 6 over here. Go ahead. C6, what will you get H as? Absolutely right. C6H14. Okay, try C10. How many hydrogen will you get? Lovely. It's 22. I hope my calculations are right. Yes, 22. Okay, try the 100th member in the series. Yes, that is 202. Isn't it easy? So you have the general formula for this class of compounds, which we call as alkanes. CnH2n plus 2. These are alkanes. Hydrocarbons which have only single bond between the carbon atoms are known as alkanes. They are saturated compounds. Clear? Okay, let's see if we can do something similar for the next set of compounds wherein there is a double bond between the two carbon atoms. This sounds easy, yes. So this is CnH H2n. And this class of compounds are known as alkenes. Notice the E over here instead of the A over here. Alkenes are hydrocarbons wherein there is a double bond between the two carbon atoms. Okay, so what will be the 50th member in this series? Very right. So this is C50H100. Am I right? Because 2 times 50 would be 100. Clear? So supposing, is that right? Yes, that's right. Correct. Have you done the calculations yourself? Lovely. Now there I had asked you the 50. That means C50. Notice over here that there is no first member. There is no compound with carbon number 1 because I cannot have CH2. 1 and 1. You see, two of the valencies of carbon are not satisfied over here. So I should have actually framed my question as what will be the formula of the compound having 50 carbon atoms over here. Okay. Now, if on the other hand, I ask you to tell me the 50, no, let me frame the question again. Determine the formula of, yeah, there goes your question. Determine the formula of 20th member in the alkene series. See, apply logic. Your first member is not having one carbon atom. The first member is having how many? Two carbon atoms. Second member is having three. Third member is having four. Sixth member will have seven carbon atoms. So 20th member will have how many carbon atoms? Work out the formula. Tell me the formula of the 20th member in the alkene series. This is a very, very important point to understand and an important question as well. Have you worked it out? Okay. Yes. 20th member means the number of carbon atoms in it will be 21. If you've not understood, just go back again to what I have explained a minute ago. Yes, you can scroll back, you can drag the slider to watch the video from a minute back. C21 and H42. Double of 21 is 42. So your 20th member would actually be C21, H42. Because your first member here, this is the first member, this is the second member, this is the third member. Look at the number of carbon atoms. One, first alkene has two carbon atoms, second alkene has three, and so on and so forth. Okay. If you got the answer right, please post a smiley in the comment box. Now let's understand logically as well why we've got this CnH2n. You see, in our original alkane, there are three hydrogen atoms attached to the carbon. Now, if I increase the number of carbons, so 1, 2, 3, 4, 5, 6, 7, 8. Now remove two hydrogen atoms. That means if your original formula for the alkane was CnH2n plus 2, for the alkene, you have removed two carbon atoms and you got the formula as CnH2n. You know my next question. Yes. Give me the formula for the unsaturated compounds having a triple bond between the carbon atoms. Move logically. You see, you are going to do away with the two more hydrogen atoms over here. So when you are removing two hydrogen, what is the number of hydrogen atoms left? Correct. So the formula, the general formula for this class of compounds becomes CnH2n minus 2. Let's see if this is right or not. So when the number of carbon atoms is 3, the number of hydrogen atoms would be 3 times 6 minus 2. Yes, C3H4. This class of compounds is what we call as alkynes. ALKYNES. Notice the Y over here. So alkanes are hydrocarbons wherein there is only single bond between the carbon atoms. Alkenes are hydrocarbons with the double bond between the carbon atoms. Alkynes are hydrocarbons with the triple bond between the carbon atoms. My question to you, what will be the 20th member in the alkyne series now? Go ahead, pause the video, solve the question, and then we'll give you the answer. Have you done it? So 20th means there will be 21 carbon atoms because again, you see, you cannot have a triple bonded compound with one carbon atom. Triple bond means you need at least two carbon atoms. So your first member is again having two carbon atoms. Second will have three. third will have 4, and so on. So the 20th member will have 21 carbon atoms. And what is the number of hydrogen atoms? 21 times 2, take away 2. What do you get? H40. C21, H40. Please pardon me in case, while recording, our mind is everywhere. I want to ensure that everything is covered. So sometimes we might go wrong. Please don't be too harsh in your comments. Let me know if there's a mistake. I'll try to correct it. There you go. You have the entire chart in front of you. Alkanes, alkenes, alkynes. So based on what we have learned so far, homologous series is a series of organic compounds with the same functional group in the carbon chain. Characteristics of homologous series. Compounds have the same functional group. So you notice that in the alkane series, there's only single bond, although single bond is not considered a functional group. But yes, we do have a homologous series of alkanes. Double bond, alkenes. Triple bond, alkenes. Each one of these can be represented by a general chemical formula, and they have the same functional group. That means here all compounds will have a double bond, not two double bonds. Because if there are two double bonds, then this formula will not apply, it will change. Triple bond, a triple bond, only one triple bond in the series. That's called alkynes. Yes, we can have more than one triple bond in the compound, but we will not go down into that much depth. So compounds have the same functional group. They can be represented by the same general chemical formula. I am sure you can fill in the blanks for me now. Alkanes, alkenes, alkynes. Can you write their general formula, please? Successive members, successive. Please don't forget the word successive over here. Successive means coming one after the other. Successive members differ by CH2 group and a molar mass of 14U. Next point. There is a regular gradation in their physical properties. Example, melting point, boiling point, solubility, etc. due to the increase in molar mass. Now let me explain you this point. To explain this point, first of all, I am going to take up the experimental data. I have some data over here. I have the boiling points here for all these compounds. So methane is negative 162 degrees Celsius. You don't have to memorize this data. You will use this data in order to organize our learning, in order to base our learning on observation and moving by logic rather than just rote learning. So if you see it, C2H4 has got a boiling point of around 104 degrees Celsius. And this is negative 47.6. Yes, I have not memorized it. I am seeing the data from a paper which I have noted, and I am using that data to explain things to you. Okay, and so my reason for saying so is to explain to you that things and the matter, the material that we share has a logic to it. It is not that you just memorize. You should try and understand things before, cramming them up. So if you see, let's see the data for the alkane series. Look at the boiling point, minus 162 degrees Celsius. All of this data is in degrees Celsius, so I will not say the unit. So negative 162, negative 89, negative 42, negative 1. What is happening to the boiling point? Yes, it is increasing as you are going up the series, as the number of carbon atoms increases, as the molar mass increases, boiling point is increasing. Observe the second series. C2H4, boiling point negative 104. C3H6, negative 47.6. C4H8, negative 6.1. You see, again, boiling point is increasing as the molar mass is increasing. Similar criteria applies and similar observation is seen in the case of alkynes, triple bonded compounds. Negative 84, negative 23.2, and a positive 8.1. Same thing is observed in the case of their state. So, for example, methane is a gas, ethane is a gas, propane is a gas, butane is a gas. Oh, I haven't introduced those words to you. Let me go back. CH4, C2H6, C3H8, C4H10, they are all gases. But if I talk about the next member, that is C5H12, that's a liquid. So you notice that there is a change in state as well. If you tabulate the data, which you don't have to do actually, this data also I have put in only to make you understand things. You do not, I repeat, you do not have to learn this data at all. Even we don't learn. We just check it online. So this gives us an important information over here. That means the boiling point is increasing as we are going up a homologous series. Same is observed for melting point, for solubility, and so on. That is why the word over here, regular gradation, that means a regular increase or a decrease, whatever. There's a regular change in their physical properties. Example, melting point, boiling point, solubility, etc., due to the increase in molar mass, due to the increase in the mass of one molecule. But because they all have the same functional group. So if I am talking about alkanes, they will all have only single bond throughout the compound. If I'm talking about an alkene, they will have at least one double bond. Yes, one double bond. Alkyne, they will have a triple bond in the compound. And because of this double and triple bond, their properties will change. They will be different from those of the alkanes. Alkenes will have similar. Now here we use the word similar. We don't use the word same. They have similar chemical properties. What do we mean by similar? Is that their rate of reaction, the speed with which they react may change as we go up in the series. Moreover, because the mass is going to increase, the chemical property does get affected. The reaction may get slower or faster. So it's not exactly same to same, but yes, the chemical properties are similar. There are certain properties which are shown by double bonded compounds. For example, reaction with bromine water, decolorizing bromine water. There are certain reactions which are shown by triple bonded compounds. That's why we say they have similar chemical properties due to the same functional group. I would like to give you time to absorb the large amount of information that you are gaining in today's video. My advice to you would be go slow, but go steady. I'll try my best to post one video every day so that you get time to absorb. I know there will be some of you who will be very keen to go ahead fast in this topic. But again, I will say go at a steady pace rather than a fast one. It is more important to be regular rather than rush up things and then, be lost later on. There's a lot of information. This topic is totally new for you. You are learning new words. You are trying to absorb how to utilize the information that is being provided to you. So please be kind to yourself. When you are learning any new definition, make sure that you write it at least 3 to 4 times. No, 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 no. Not to memorize it. But when you write it 4 to 5 times, you will come across certain words which you may miss, you may, forget the first time. So, for example, a very common mistake. Homologous series of compounds with the same functional group. What is it? It's a series of organic compounds um, with the same functional group. So sometimes the students forget the word functional with the same group. Okay, it's the same functional group. In a carbon chain is called a homologous series. These terms like these are known as the key terms. We need them in order to study a topic scientifically. See, I gave you the term functional group over here to explain, characterizes, functions from its name. But then I also gave you a proper definition of functional group because these are the terms that you need in order to connect to scientific knowledge, chemical behavior, organic compound. So these are key terms. If you miss out, so for example, if I just say like this, atoms or atom or group which affect the chemical behavior of, let's say I don't write group, organic as well. Look at the meaning, it changes. Atom or group, what do you mean by group? Which affect the chemical behavior of a compound. So do I mean to say I'm talking about MgCl2? Because this is also an atom, magnesium, chlorine, right? That is why I am telling you that you should write the definition at least 3 to 4 times to get a hang of the important keywords required by any curriculum. Trust me, from my experience, I can tell you that all curriculums look out for these keywords, be it GCSE, A levels, ICSC, CBSE, any state board. In order to explain your answer, you need the keywords in place. I hope you've noted down the points for what is homologous series. Yes, according to your curriculum, you can define homologous series in different ways. This is the closest that I have taken. Even I would define homologous series in different ways. So series of organic compounds with the same functional group in an organic compound which defines its properties. I could also define homologous series as a series of organic compounds having the same functional group such that the successive members differ by CH2 group and have similar chemical properties. This is another, I would say, more exact way to define and less confusing way to define homologous series. But my advice to you would be to follow your curriculum textbook and answer according to that. So, series of organic compounds. This is another definition for homologous series. Right? So, I've given you two definitions. As I repeat, you can follow the definition as per your curriculum. Now, I did mention functional group. That means a group or a feature, we can say, which defines the functions or the chemical properties of an organic compound. So, for example, alkanes are saturated compounds. They are saturated. They are fully happy. Each carbon has formed 4 single covalent bonds. You see, single covalent bond, 1 dash. So it's fully happy, fully satisfied, and it does not like to be disturbed very often. So that is why we find that they don't react easily. Their reactivity is low. Alkenes, on the other hand, they are bonded, wherein the two carbon atoms are bonded by a double covalent bond. Now, because there is a double covalent bond, that means there is a high concentration of electrons. Now, what is the logic behind it? For that, you will have to study bonding. You have to draw the structures. I've dealt this in separate videos on the channel. So because of the double covalent bond, the concentration of electrons here is high. That means they are finding it difficult to hold those two electrons in place. Sorry, four electrons in place. So what happens over here is their reactivity becomes a little more. While triple bond means there are six electrons between these two. That means just like six children being handled by two adults. Difficult, isn't it? Yes. So what happens is this becomes even more reactive. So that means their reactivity is even higher than those of alkenes. So these are these features which define the chemical behavior of a compound. Now, can the hydrogen atom be replaced only by double or triple bonds? No, there are other ways as well. So, for example, the hydrogen over here can be replaced by a halogen atom. A halogen means fluorine, chlorine, bromine, iodine. That is, the name comes from salt former. Fluorine, chlorine, bromine, iodine, FCl, Bri, any of this can replace the hydrogen atom. Two of the hydrogen atoms can also be replaced by the halogen atom. We will keep the thing simple and we will just replace one of the hydrogen by chlorine. We can also have a hydrogen atom being replaced by a group of atoms. So you see, we've got OH replacing the hydrogen. So you notice the definition that I've given you, atom or group of atoms. So now when the hydrogen becomes replaced by OH, now this compound becomes what we call as an alcohol. When it is the halogen replacing a hydrogen, that means it becomes a halogen derivative, or more exactly, halogenoalkane. It is also known as haloalkane. Haloalkane. Oh, yes, I can't be bothered by the exact pronunciation. I'm not an English teacher. So haloalkane, halogenoalkane, alcohol. I could also have a group of another type of atoms replacing the hydrogen, and that group of atoms could be CHO. Oh, what is this? This is an aldehyde. I could also have a COOH group here. What is this? It's a carboxylic acid. You are imbibing a lot of information in this video, lot of it. I made things simple for you. You see over here, functional group, double bond. The name of these set of compounds is alkenes. What will be the structure of the functional group? Yes, a double bond between the carbon atoms. You can tabulate it. Oh, yes, I see that smile and you're happy. Triple bond, the class of organic compounds. What is the name of these compounds? Class of organic compounds. Triple bond means they are known as alkynes, so there'll be a triple bond between the carbon atoms. When the functional group is a halogen, the class of organic compounds is halogen derivatives. You can also call it as haloalkanes. You can also call it as halogenoalkanes. So the functional group is just F, Cl, Br, I, and so on. What is this dash dash that I've left everywhere? You see, is this a mistake? You see this single line, single line? Yes, these are the free valencies. Free valencies means how many bonds can that atom or group form. That is the number of bonds that an atom can form. So if I am saying a single line, that means it can only form a single bond, single bond, single bond, single bond for the halogens. OH, that means when you have the group OH present. The class of organic compounds is alcohols. The functional group, as you can see, is OH. CHO, that means the functional group over here is a CHO. What is this class of organic compounds? Aldehydes. Look at the structure. There is a C, H, and a double bond O. Now, carbon overall can form 4 bonds, but it has only formed 1, 2, 3. There's one more bond that it can form. So the free valency for this will be a single one. Look at the ketones. C double bond O. Oh, look at that. What is this V over here that I have drawn? Okay. Don't worry. I've simplified that V for you. So carbon forms a double bond with oxygen. Why does it form a double bond with oxygen? Yes, because the valency of oxygen is 2. Oxygen, in order to be stable, needs 2 more electrons, needs to form 2 bonds. Either it will form these 2 bonds with another atom, with the same atom, or it can form these 2 bonds with the 2 different atoms, as in the case of alcohols. So here, in the case of ketones, it's C double bond O, and there are 2 free valencies over here. Look at carboxylic acid, COOH. C double bond O, single bond OH. So how many free valencies do you see in the case of carboxylic acid? Yes, there is just one free valency. So what we are going to do is, let's write down the free valencies over here. So slash free valency. Of course, in the case of alkanes, alkenes, alkynes, we can't define a free valency. In the case of halogen derivatives, free valency is 1. In the case of alcohols, it is, look at the number of dash that you see over here. 1, single. 1. How many free valencies in the case of ketones? Look carefully. Yes, there are 2 free valencies. How many free valencies in the case of carboxylic acid? 1. Absolutely right. So would you like to draw this chart? Would you like to copy it down so that you can have something for offline reference? Oh yes, I've drawn a column for free valency, but anyway, we've done that free valency in the bracket. You can do it as a separate column as well. You can pause the video at any point of time, note down. Are you noting it down here? This is a complete chart for the functional groups. Should be helpful. Now you see, in the case of alcohols, aldehydes, halogen derivatives, We have atoms other than hydrogen also in the compound. So they are no longer just hydrocarbons. So if I have a compound like C, so these are all hydrogen, and there is a chlorine over here. Now, I cannot call it as a hydrocarbon now. It's an organic compound, yes, but it's not a hydrocarbon because it has atoms other than hydrogen and carbon. The atoms other than hydrogen and carbon in an organic compound is known as a heteroatom. Any atom other than carbon or hydrogen in an organic compound is known as a heteroatom. This can be a single atom, a group of atoms, or Cl, Bri, CHO, and so on. These atoms or groups define the chemical properties, hence the name functional group. I've also given you the definition of free valency. You can either write this one or you can write the one on the previous slide, or you follow the one which is there in your curriculum booklet. Now you see, we have absorbed, we have learned quite a few things. I've also taught quite a lot today. I will give you a day to absorb this entire information, to practice writing as much as you can, so that you are ready for the next phase of your learning journey. And I want you to be very, very happy when you are learning this topic. So please go slow. Please be kind to yourself, okay? And make sure that you follow the rules of the channel. Write and understand. It's very, very essential. See you in the next video. Take care of yourself. Do subscribe for more videos in chemistry and don't forget to share the channel with friends and classmates. See you in the next video.